Just a reminder, Nancy, can you pay attention to me? Probably you can figure out which one or which your mistake. Concrete floor slab, the elevation will be 10 or 20 feet, whatever. A, cancel this one. View, drawing a grid, insert, point, 0, 0. Then, you remember, ten, 0. 25, 0. 35, 0. 45, 0. Then we have 15, 0. No, we have 0, 15, 10, 15, 25, 15, 35, 15, 45, 15. Then we have 0, 25, have 10, 25, have 25, 25, have 35, 25, have 45, 25. 0 and 50. I think I have a mistake here. $45, yeah, I'm good. 0, 45, 10, 45, 25, 45, 35, 45, and then 50, 45. This one should be 50. Yeah. So I have a little mistake here. 25. This one should be 50, not 45. 50. Okay. View point load. There you go. Insert beams, explicit shape. This little icon to define a concrete, a rectangular cross section. Your depth 30, your width 60. Okay. Apply. I can draw my beams like this. Insert columns, explicit shape, define concrete, rectangular, 20-inch by 20-inch. Apply. I can draw the columns at the locations. Insert slabs, thickness 5-inch, draw slabs, apply. I am done. You have to check what you did. It's very important. So I need to hit this little icon and watch it isometric to figure out I am good. Yeah, I'm good. Everything is drawn. Insert loads, area load, it's an office building. Click here, apply. I can click at each location. Please don't click at this area. Don't click at this area because we don't have slab. We don't have anything. It's stairs, I know, but it's not in the same level of the slab. So don't click at this location. Make sure your load combination is good, just to check. Then I can solve. Nothing happened. Everything is good. Everything is good. Okay. So view point label one more time. View beam label one more time. This little icon to hide everything. Guys, from this little icon, I can figure out the results of the slab, color fill, contour, MZ, combination, dead plus life, strength. Okay, I can watch the moment on the slab. Okay. The same little icon, I can watch MX, the moment on the other direction. From this moment and this scale, I can figure out the values of the moment. Results, bending, concrete, I can figure out the moment on the beam. And results, column forces, I can figure out the reaction on the beam as a dead load alone and as a live load alone. So each column, I can figure out what is the reaction on this column as a dead load or live load, each one alone. Just to give you a hint, we have columns CS1, CS2, CS3, CS4 until CS20. We have 20 columns. How can I show up the labels of each column? From this little icon also. We have here something called beam column wall. Beam column wall. For columns, you can showing label. Okay, here is the name of each column. I would like to hide the variable. So this little icon from beams, columns, walls. For show columns, I can label each column. Okay, so the name of each column is shown up. Where is column number 7? Column number 7, CS7, with dead load reaction 47.018 kept, and the live load reaction 9.67. Where is column number CS7? Here you go. This is the column CS7. So what we did last meeting for design of columns, you remember that? We designed the column here on this Excel sheet. So the label of this column, where is each column? Here you go. I can print this layout because this layout showing up the label of the column and the location of this column. Any question regarding this point? Any question so far? So from this point, finally, I designed slab, beam, and the column. And I can figure out the dead load reaction on each column and the life load reaction on each column. And remember, these reactions coming from RISA floor for one floor. So dead load reaction must be multiplied by number of floors, and the life load reaction must be multiplied by number of floors. Why? Because when you decide to design footing, you have to give me what is the value of dead load reaction and what is the value of life load reaction on the column. Do you remember that? If you open your previous note, you can find any problem to design a square footing or rectangular footing or any footing. I have to give you what is the dead load reaction and what is the life load reaction. One more time, I covered this many times before. The dead load reaction and the life load reaction are not these values. No, these values for only one floor. But your footing is supporting the whole building. So you have to multiply this value by number of floors. This value by number of floors. This value by number of floors. So each value for dead load must be multiplied by number of floors. And each value of life load must be multiplied by number of floors. So before starting to design foundation, you have to prepare the final reaction on each column, because the final reaction on each column will be used to design. Okay. The next step, we need to open another software called RisaFoundation. So I'm gonna close this one. Guys, at this point, I didn't cover last meeting. How can I show up the label of each column? From this little icon, we have a tab here called beams, columns, walls. For show columns, labeling, I can label the, or showing up the label of the columns. Okay, so the label is shown up. So you need to print this layout to showing me where is the column and what is the label of this column. I'm gonna close it and open a new software called RisaFoundation. Here you go, this one. Close. I will not choose anything, just close. What do you think? Do you think we have a different window, different format, or different? No, it looks like the same, like Risa floor, like Risa 2D. Before starting, I have question, and I need answer. Yeah, exactly the same. My question is, anybody can tell me where are the locations of footing? How can I figure out the location of footing? How can I distribute them along or among the structure? Be careful to don't answer stupid answer. Where is the location of the footing? Thank you, Oliver. That makes sense. My question is stupid. I don't need to ask this question. Each column has footing. So at each location of the column, we have footing. So you don't need to answer this question because you already have the layout of the floor and you already have the location of column. At this column, we have a footing. At this column, we have a footing. At this column, we have a footing. So first step in this software, if you hide the drawing again, first step, we need to insert points. So how can I figure out the coordinate of each footing? You don't need to figure them out because the coordinate will be the same like column. Do you remember that? 10, 0, 25, 0, 35, 0, 50, 0, 0, 15, 10, 15, 25, 15, 35, 15, 50, 15, 0, 25, yes, 10, 25, 25, 25, 35, 25, 50, 25. 0, 45, 10, 45, 35, I'm sorry, 25, 45, 35, 45, 50, 45. View, point, there you go. And view, point, I'm sorry. There you go. So the location of each footing in your building will be at the same location of each column. Insert point. We have the same coordinate, z in horizontal, x in vertical. What do you think? Looks good. Until this moment, looks good. So first step, we need to insert each, I'm sorry, wait. Insert each joint, and the coordinate of each joint will be the same coordinate for columns. That makes sense. Second step, we need to insert the loads, but it's not easy because we need to apply dead load alone and live load alone. You don't need to combine dead plus live and enter them one time. No, we need to enter dead load alone and the live load alone. Remember, guys, remember, your dead load reaction from RisaFloor must be multiplied by 10. I assumed number of floors, 10 floors. So I multiplied the reaction from Risa by 10 to get the total dead load, and the live load reaction times 10 to get the total live load. Let's start. Column CS1, this one. Okay, so insert loads, point load or line or area. I think the column is a point load. Dead load, what is the magnitude for dead load? 106.4. In Y direction, so it should be negative. Okay, all positive Y are downward. No, it should be positive. I'm sorry. All positive Y loads are downward. Your load is downward, so your value will be positive. In direction Y, in dead load, apply at this point. Escape. Second column. Let's do let's do the second column. Node number 2. I'm trying to define total dead load alone. First, we have dead load 234.4. So insert loads, point load, dead load 234.4. Apply, just click on this node. Escape. Column number 3. We have total dead load reaction 215.9, for example. So insert loads, point load. We have how much? 215.9. Apply. Keep going. Okay, let's do one more. Number 4, 224.9. Insert loads, point 224.9, I think. It's silly a little bit. Apply. The last one, N5, column number 5, 144.3. Insert load, point 144.3. Apply. Just click here. You have to continue until you finish up the total 20 columns. Then I will repeat these steps to enter the total life load. First column, 13.8. So insert loads, point load. What should I do first? I need to change from dead load to life load. 13.8, apply. Go ahead and click on the first column. Don't worry, the dead loads are exist. Second column, 48.9. Insert load, point load, 38.9. That's right. 48. Life load. Apply. Just click. Then 43.7. $43.7. 46.2. Uh, 23.9. And you have to continue until you finish up the whole columns. Any questions so far? Yes, these loads are not factored. I'm defining dead load alone without factor coming from Risa. Guys, do you remember Risa? We can show up the dead load alone and the life load alone. Okay, time, number of floors. Any questions so far? Don't forget, because this point is very important. Many engineers did this fatal mistake. Don't forget to multiply the dead and the life load reaction from Risa floor by number of floors. It should be the final shape of this layout. It should be something like this for dead load and something like this for life load. If you apply your loads for the whole column. we need to define few parameters. The most important parameters is soil definition. We have here a little menus. We have soil definitions, allowable bearing capacity. Do you remember this term? This term must be given in your problem. What is the bearing capacity? 5 kb per square feet, or 5,000 pound per square feet. But in this case, we have your units kb. SF means kb per square feet. 5, for example. Okay, close. We have something here called also footing definitions. General, what is the minimum reinforcement? What is the maximum reinforcement? You can define if you want. One more thing for geometry. Do you like to make sure each footing to be designed as a square? Because the software will select the dimension, will calculate area required, and then convert this area required to length and width. So probably it can be rectangle, probably it can be square. Do you like to force the software to design all footing to be square? If you would like, you need to highlight this option. One more time. This one coming from footing definitions. You need to define something. From geometry, you can force the design to be all footing to be square, if you would like. Also, you can define what is the maximum thickness, what is the minimum thickness, what is the thickness increment. Do you like integer numbers? So you have to make increment 2 inch. You know, what is the maximum length? What is the minimum length? What is the maximum width? What is the minimum width? I know the software will design, but you can apply few restrictions if you would like. If you would like. Okay? So I will design, no, I will not force the software to design all footing to be square. We are good right now. We are good. We need to draw footing. We have a little icon here. This one. Footing. Footing. Apply. I have a footing here. Another footing. Another footing. One of you will ask me, hey, the whole footing are equal. Yeah, we didn't design yet. We are just saying to the software, hey, I have a footing here. This little icon. Once you put your footing, you can solve. Load combination, you have the load combination, don't worry, just to check, and then go ahead and solve. Guys, what did you notice? The dimension of the footing changed. Yeah, based on your design. This footing has a different dimension than this one, than this one, than this one, than this one. What happened here? Nothing, because you didn't apply load. For my example, I didn't apply load here, so the dimension is 0, nothing. We don't have load, so we don't have the footing. Very, 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 very small footing. So if you apply your loads for the whole column, you can find the same footing dimension. So it's very easy to use RisaFoundation. Just you need to define joints for each column, because the joint of each column will be the same joint for each footing. Second step, you need to apply at each joint what is the total dead load, what is the total life load at each column. Then you need to define some parameters. And it's very important. What is the bearing capacity for the soil? Then from this little icon, you can draw a footing at each column. Then solve. Once you solve it, the dimension of each footing will be different, because each footing will have a different design. Let's see this one. Just a second. Okay. We have something here called footing results. At each node, for example, node number 1, this one, the dimension of the footing will be 4 feet length, 6.5 feet width, thickness 20 inch. If you would like to see the details for this footing at node number 1, you can click detail report for current item. Can show you the dimension of the footing and the reinforcement and check of shear and check of overturning, of sliding. We don't have issue with these things. So check of shear, check of bunch. How can I read this number? If there is something unsafe, it will tell you with red color. But to make sure, V ultimate 118, V ultimate design divide the design 1.39. So this number is smaller than 1, it's safe. For shear, V ultimate and the ratio between the ultimate and the design value. So these values below 1, it will be safe. So you can print this report, but this report for only one footing at N1. For N2, we have a footing 6.5 times 9.5 and the thickness 22. If you would like to see the details for the footing at N2, okay, N2, just click detail report for current item. You can watch the detail for this one and see the check on shear and bunch. Each footing has a different thickness. That's right. I will ask you a question and I need answer. How can I force the software to make all footing with the same thickness? Do you know how? Okay. Footing definitions. For geometry, you are letting the program to select length and width, but don't exceed these limits. You are defining the maximum length, maximum width, minimum width. Also, we have maximum thickness and we have minimum thickness. What will happen if I define the minimum thickness 24 and the maximum thickness the same? 24 and 24. What will happen? The program or the software will understand the minimum thickness is 24, the maximum thickness is 24. You will see all footing will have the same thickness. If you would like to force square design, okay, then I will solve one more time. Can you watch? Can you watch what happened? This one is a square, this one is a square, this one is a square. Let's see. footing results. N2, for example, 8 feet times 8 feet, 24 inch thickness. Footing at N1, 5.5 times 5.5, 24 inch. At N8, the same. N4, 8 times 8, 24. I understand you will spend too much time to define the load at each node, but remember, you can design 20 footing in 1 second. Do you remember the problem in the third exam to design a square isolated footing? To figure out the dimension, to figure out the thickness, to check the bunch stress, to check the shear stress, to figure out the bending moment, how much steel reinforcement, all of this stuff for only 1 footing. But in this case, you can define whatever the number of footing in a second. And the software can tell you what is the dimension of each one and the thickness. And you can print a detailed report telling you everything about this footing, including reinforcement. In X direction, we will need 7 bars, size 6. In Z direction, we will need 7 bars, number 6. Any question?
Dr. Amy? Yeah. Do you need us to include all of these reports for every single individual footing?
No, just 1 or 2.
Oh, just a few of them? Okay.
You need to print this layout. Okay. And just only 1 or 2 reports for 2 footing only.
Okay, thanks, sir.
Okay. So RisaFoundation can help you to design your isolated footing in a second. You don't need to make any check or anything. Just draw, define your load, and then solve. Any other question?
Dr. Amy?
Yeah.
On the term project one, where it says 10 floors, you said you were going to show us later how to do 10 floors on RisaFoundation. Can we do it on RisaFoundation or?
No. RisaFoundation, I did already. Do you remember when I multiplied the reaction dead load by number of floors?
Oh, from on
that's
one,
it.
From last.
Yeah. Just calculations. We don't need to define. Just calculations. Your reaction from Risa floor, multiply it by 10 before applying this load to RisaFoundation.